Hello and welcome back. So now that we have wrapped up the heart of the Space Fighter engine, let's go ahead and turn our attention to some of the bonus content that we had discussed earlier. We talked about implementing such things as the Powerup class, getting a star field in place, as well as getting some heat-seeking or just enemy-seeking missiles in place. So let's kick things off with a quick look at a Powerup system that we can employ in Space Fighter, where we will begin in this video with the creation of a simple Powerup class that will serve as the foundation for this system, in which we can then extend the Powerup class into very specific power-ups for our player's ship. Logan?
Now, before we get started and begin coding, I would like to give a brief overview of how this Powerup system is going to work. Beginning with the base Powerup class, the idea of the Powerup is that it's just a simple game node that has specific collision handling. This game node called Powerup is going to be set to collide with anything in the player ship's list, and upon collision it will fire off a call to an apply Powerup method. The idea of this class is that any subsequent Powerup that is written will simply extend it, and then it's given apply functionality that it can override.
Okay.
So that way all of the base idea of ship collision handling will be handled in the base. Then we'll move on to a health Powerup to give a demonstration of the Powerup's use, and then later in time we may make other Powerups for other uses. So with that, let's go ahead and begin on the Powerup class itself. We'll go over to our game folder and add a new item. And this item is, of course, the Powerup class. And once again, as always, we will begin with some namespace cleanup. We'll take off the game sub namespace. And I'm also going to take out the using for system.txt, which we won't be using, and we will need access to Microsoft.xna.framework. With that in place, we can now turn our attention to the class itself. And the key with Powerup is, as I said earlier, it needs to extend game node. So Powerup extending game node takes care of the class. We would need the colon operator to convey the fact that it extends. Alright, the first thing we'll address inside of the Powerup class is its constructor. Inside of the Powerup's constructor is where we will set up the Powerup's collision list. So let's put in a public constructor for Powerup. And we're going to take in the usual sprite sheet to satisfy the node constructor. So a sprite sheet parameter, simply called sprite sheet, as we've done many times in the past. We'll then put in our call to the base constructor and pass along that sprite sheet. Now, inside of the constructor, once again, we want this Powerup to be checked, or to run a collision check against any player ship to see if it has collided with a player ship. So that means we need to set up its collision list. And that collision list is going to point to the player ships list, which is found in the player ship class, and it is that player ship's static list. So this is the line that establishes the fact that any Powerup is going to collide with player ships. Moving on from here, I want to get the apply Powerup method in place. This is going to be the method that is called and in subsequent Powerup classes is overridden to basically subscribe to the fact that an apply action needs to be performed. The key here is that it's going to get the type passed along resolved to a specific ship so that we don't always have to reevaluate the node we collided with. That'll become clear here in just a moment as we combine this with collide. We'll see where we have to make the jump from a node we collided with to a ship that we wish to apply in effect to. Now the apply method is going to be virtual in nature, as the base Powerup class is not going to provide any actual implementation itself. So once again, this method is going to be protected, and it is going to be virtual. The return type will be void, and the name is apply Powerup. We're going to have this method take in a player ship parameter. We'll call this ship, and this will be used to pass in which ship the effect, or the effect of this Powerup, which ship should it be applied to. And finally, we're going to have an empty set of braces out to the side, as we're not providing an actual implementation in the base Powerup. So another way that can be read is that the base Powerup has no effect. Now I'm actually going to jump up a few lines leaving apply powerup is the last method in the class. And I'm going to do that because we're going to address some methods that we're going to need to override. One from GameNode and one from Node. The method in GameNode that we're interested in is the collide method. We're going to put in an override so that we override the collide method, and this is where we begin the check that is eventually going to call apply powerup, because the way the application of the effect works is you gain the advantage of the powerup the moment you run into it. So in this collide, what we're going to do is check and see if the node that we collided with, whether or not that node was a ship. We'll do that by making a player ship variable, which we'll call ship, and that variable will be initialized to the given node casted to player ship. So that is node as player ship. And give me a moment on typing. We'll have player ship, the type that we're casting to. Now, if the incoming node was something other than a player ship, we're of course going to have null as the value of our variable. So we'll do a check on that variable to say if the ship is not null, then we know we have indeed collided with a player ship, and that means we can apply the powerup's effect. So a call to apply powerup, and we'll pass along that ship. And once again, this is what I mentioned briefly earlier as apply powerup doesn't force you to do all of the casting and type checking as we're doing here. We're doing that from collide itself. Now, one other thing that happens when a ship collides or runs into a powerup is that after that powerup's effect is used and applied, the powerup goes away. It is as though you have collected the powerup. So on screen, that means we need to remove the powerup from gameplay. Otherwise, as you would run through the powerup, you get the effect continuously reapplied every game tick. So as the final thing instead of collide, we'll run a call to this.remove to take the powerup out of gameplay. And there's one last thing that we need to address. This is just a cleanup thing, and that is we need to make sure that if a power-up manages to slide off screen without being picked up, that it's simply taken out of play. Again, this is the same as many of the game nodes, many other things such as asteroids or projectiles or any other game node that has no relevance once it goes off screen. We remove it from gameplay so that it's no longer considered. And we'll do this with a call to, an override to update, where we will make a call to this.remove off screen. That will of course run the check. If the node is in fact off screen, if the power-up is in fact off screen, it gets taken out of gameplay. And we'll leave our call to base.update so that any other things such as potentially collision detection and anything else that game nodes need to do gets called. Now with all of this in place, that is really all there is to the power-up class. I'm going to build briefly to make sure that there's no syntax errors. And, passing, I see. When I was saying that I was making a parameter in the constructor called sprite sheet, I seem to have failed to type the word sheet, which is what confused it about the type when I was passing it to the base constructor. Now if we build, that removes that syntax error, and we have our power-up class in place and ready for use. So the next thing we'll do is we'll move on and make a test power-up. Really, it's more than a test. It's an actual power-up we'll use in Spacefighter, and that is the health power-up. Over in the game class, we'll add a new item, and this item's name will be power-up health. And as always, beginning with a little bit of namespace cleanup. And I don't think we need to mess around with the using statements, though since this is an actual power-up that's going to be used in Spacefighter, we do have some configuration. While I'm right here, though, at the class's definition, I will go ahead and specify that the power-up health extends power-up. And I guess to go along with that, I should probably put in the constructor to satisfy its need for constructor with parameters. To avoid having to retype the whole method signature for the constructor, I'm actually going to get lazy and steal the one from inside of power-up, paste it in, and then just clean it up. Since we're not actually making too many changes, actually I take that back. If we need to set up some things for the way that it works, we'll get to those in a minute. I'll stay on target. I'll get this cleaned up so that we have the simple definition of the constructor, the name health constructor, of course being the public constructor for powerup health. And that takes care of the class. And we'll hold off on any error checking until we get some of the configuration in place. Again, this configuration is because this being the health powerup means it needs to know what sprite sheet it's going to use as a game node and what is the actual health value gained by picking up a health powerup. We'll go to the config class to define both of these. So here in the bottom of the config class, let's start with the sprite sheet used by the health powerup. To ease the creation of that field, I'm actually going to steal a convenient sprite sheet field. I'm actually going to grab the enemy bullet sheet, put that into place so that we can change the name over to health sprite sheet. Just grab the first two words of this definition for health sprite sheet. The name of this is going to be powerup_health. And the animation settings for this will simply be one tile by one tile. The current graphic used for health is not animated, so we'll leave it set to only one tile. And we'll set the frame rate to 1 frame a second just so that there's not much time given to the animation of that single frame. And we'll also leave in the sprite sheet mode for no damage texture because this is a health powerup. It doesn't collide with projectiles and it doesn't ever maintain damage and stay on screen. It gets picked up and that's the end of its life. One final field we need is the health powerup value. So we'll make a new field for its configuration, a public static integer field called health powerup value. And we'll say that that value is equal to 25. Alright, with the configuration out of the way, we should be able to turn our attention back to the actual powerup health class, and then handle the case of the actual pickup. So since this is indeed a powerup, we should be able to override the apply powerup method. Inside of apply powerup, I'm actually going to remove the call to base because we know that that in powerup does nothing. So the one thing that we want to have here, since we're inside of apply powerup, which if the code reaches this point, that means a ship must have collided with a health powerup. And this is the ship that has collided with this specific powerup. So this is the ship that needs to have its health incremented by the health powerup's value. So the way we'll do that is, well, the most simplistic way we can do that is by taking the ship's health and simply incrementing it by 25. Of course, that value given as config.health powerup value. And that will indeed cause the ship's health to increase every time we hit the powerup. There is a flaw in using this, and that is there is no cap on how much health can be gained, which means we can easily exceed our default health of 100. But just to show that this is in fact working, I'll come back to the calculation necessary to cap the health. We'll leave this alone because it does indeed have an effect, and this will allow us to test and make sure that our power-up system is working. So before we address the final setting for this, I'm going to move on to some of the level considerations for the health power-up. Because here at this point, we need to get the health power-up in play in the game. Now, instead of going back to the game class and hard coding in a creation instruction to get a health power-up in place, I'm going to go and add support for the health power-up to the level class so that the level class can be instructed to spawn them specifically using fewer lines of code, or even allow them to spawn health power-ups as one of the randomly picked items when we did our level stress test. Before I move away from the power-up health class, I would like to build briefly, just to make sure that this has been built and that there are no errors. Now moving over to level, the first thing we need to do with level, of course, is we need to add health power-up support to the level class. And that begins up here with the item type enumeration. We need to have an item type that indicates health power-up. I'll copy one of the existing lines here, the enemy interceptor, and simply change its name to power-up health. Moving on from here, we're going to go down to the spawn item method and put in support for health power-ups. So down here in spawn item, this is where we take in a specific item and run a different line depending on what the item type was. So I'll copy the last line, the else if of the if statement, and paste it to duplicate it so that I can watch out for an item type of power-up health. It means if we encounter a power-up health, then the node instantiated will be a new power-up health instance, and the sprite sheet that is going to be used for that instance is going to be given as health sprite sheet. So that's, with those two lines, is the core of the support. Now level has support for health power-ups, so now all that's left is to use it. That means we can change our individual add item lines and even extend our support so that the randomizer can choose a health power-up as one of the things usable. What I'm going to do is I'm going to begin with, let's see, reading this back. That means we have an enemy that spawns in the center of the screen followed by 2 asteroids. I'm going to take one of those asteroids and change it over to a health power-up. So let's take the first one and change its item type to power-up health, and that way we know exactly which one it should be. It's subtracted from the center, so this should be the item on the left. So now if we build and run the game, after our enemy, we see we have a health power-up. If we get damaged by the enemy and then pick up the power-up, we gain health back. But let's take a look at the current idea of health capping. That is, what would happen if we did not take any damage and grabbed the health power-up? 125. Or if we had simply taken less than 25 damage and picked up the item, there we have 105. So we're in a scenario where picking up health power-ups allows us to go over. So in order to give a cap, meaning a cap that we can't exceed, what we'll do is we'll use the math.min function to decide to get a value of which is less, the incremented health of the ship or the ship's default health of 100. So we'll run this as math.min, and then we'll give in a minimum between the ship's health. As a matter of fact, we'll change the entire assignment. Instead of incrementing health directly, we'll set it to the value returned by math.min. So it's the minimum of ship.health plus the power value. So again, this is now the incrementing. So this is the health plus equals 25. So that's one possible value. And the other possible value is the cap. That is the ship's default health, or config.shipHealth. So here, if we were to run this calculation, find a value of 105, we'll end up picking the original health, which was 100, which the min function will notice is less, and will be the value returned and stored in health. This can be demonstrated now by taking some damage, so 80 health, which originally resulted in 105, but now results in only 100 points of damage, giving ourselves the final cap. Now, to ensure that we can't ever go over 100, I'm also going to go to level, and this is where we'll go in and change support in the randomization. If you recall, at the end of our predefined items in the level, we have a loop assign 100,000 more items, where each item is of random type. You'll notice that the selector between item types gives only the first 2. If we change it to 3, we'll be able to randomly select all of the items. So before, when we talked about enhancing the randomizer, that's all it really meant, was expanding the range. So now let's take some damage, restore to 100, and then give it just a moment while we get past all the others. As a matter of fact, if we test this, there we go. Now we've gotten into the additional random items, and you'll notice that as we encounter health power-ups, we're still at 100. If we take damage, and some more damage, and then a health power-up, 97. If we wait for another health power-up, 100. And if we wait for a final health power-up, which is, we're at the mercy of the randomizer, so if we continue waiting, surely here in a few minutes we should get, there's a health power-up. We stay at 100 and stay at 100. So again, now that that has been more extensively tested, we know that we are in fact capped in health on the ship. We have our level system set up to handle health power-ups, and we have tested the power-up system. So that is what we needed to get accomplished in this lesson, and that wraps things up.